Okay, so here I've already written everything on the board, and now I'm just going to explain what this means. Now, hopefully we're all familiar with LRIM, RM, MRIM, and TSAM, which are our Riemann Sum approximations. This is just going to be an extension of it based off of Riemann Sums for volume instead of for area. So we understand how to calculate LRIM, RM, MRIM, and TSAM, right? So for these three, which is the rectangle, right? What we do is we take the left-hand points. So our x values, if these are our x values, would be 1, 2, 3, and 4 for the left-hand Riemann sum. For the right hand, it would be 2, 3, 4, 5, and for the midpoint, it would be 1.5, 2.5, 3.5, and so on. All right? Now for TSAM, it would be a little bit different. You would do 1 and 2, 3 and 4, 4 and 5. Right? And those would be your 4. 1 and 2, 2 and 3, 3 and 4, 4 and 5. Those would be your 4 trapezoids. Okay? Because you would have two bases, right? Hopefully we're already all familiar with that. Now, if going off of these three, right? Because these three can be grouped in the same category as the rectangle sums. Now, for a rectangle sum, if we take a rectangle and we rotate it around the x-axis, so say this function is being rotated around the x-axis and we're trying to find the volume of it, right? So the volume, well, what does the rectangle create when it's rotating around the x-axis? It creates a cylinder, and the height of the cylinder is just going to be the width of this rectangle, and the radius of the cylinder is just going to be the length. Of this rectangle. So that means knowing that the volume of the cylinder is pi r squared h, we can also assume that the area of this rectangle is RH. Okay? Knowing this, right, we can say, okay, so that means the volume is pi r squared times delta x, and the radius is just the value for these rectangles, because the rectangles only have a constant height, right? It's just going to be these values that you plug in. So for left hand, it's going to be 1, 2, 3, 4, and right hand 2, 3, 4, 5, and midpoint, as I had said before, right? And that's it. That's the only thing that changes here. So this is going to be your formula for the volume of a Riemann sum based off of these rectangle sums, okay? Now for a trapezoid, it's going to be a little bit more difficult to find that volume because of the fact that when you take a trapezoid and you rotate it around the x-axis, right? What you get is something that looks like this. This looks like part of a cone, but it's not actually a full cone. So it's kind of hard to actually calculate the volume of this shape, okay? And the only way to do it, knowing the function, would be to use an integral, and that defeats the entire purpose of using a Riemann sum to find the volume, because if we end up using an integral, that destroys the entire reason for why we are using the Riemann sum. Now, so what I have created is a method that allows us to cheat this system. Now, knowing that the area of the trapezoid is this, 1/2 base 1 plus base 2 times the height, and the height is just going to be delta x, you know, your change in your interval, which is also here, right? And knowing that the total volume is just the sum of all the volumes of every single one of these shapes, right? So for the total volume, if we were to do a rectangle sum, would just be the sum of all of these cylinders, okay? But the area of a trapezoid is this, right? So, but if we say that we want to convert the trapezoid to a rectangle, what we do is, knowing that the area of the rectangle is RH, we could say, okay, so this is the height, so this must be the radius. And if this is the radius, and we know the volume of a cylinder is this, then we know that the volume of a trapezoid to the cylinder, right, is going to be this, which is we replaced R with this, and not f of x, because it's kind of hard to say, because it would be f of x1 plus f of x2, but that's kind of complicated to talk about. So instead, it's just going to be, okay, so this is just this, like that. And that's the only thing that changes between these two. This is just this part of the trapezoid, and this is just the value in the table. And that's the only difference between these. So this applies to all three of these rectangle sums, and this one applies to the TSAM. And remember that to find the Riemann sum, you need to take the sum, of course, of all of the volumes that you calculate using this method. So if you have 4 rectangles, you would do this method for the 4 rectangles and then sum them all together. All right, so you would sum the 4 cylinders and you would get the approximation of the volume. And for this one, you would take, say you were using this function right here, and you were to use 4 trapezoids, as I've done already here, well, all you would do, right, is you would say, okay, that means that base 1 plus base 2 over 2, which is our radius, right? All we need to do is say, okay, so we use this for every single one of these trapezoids, right? And then after we do that, we just sum them all together, and what do we get? We get the Riemann sum for the volume, and hopefully this explains what you need to do in order to calculate the volume using such an approximation.